Okay, so now that we've looked at kinetic energy, we want to look at potential energy. So let's take a look at number 2 on your kinetic and potential energy worksheet. So number 2 says a baby carriage is sitting at the top of a hill that is 21 meters high. The carriage with the baby weighs 12 newtons. If you hadn't figured out yet, newton is a form of weight. Somewhere in the physics world, now remember we're in our physics section, they decided that they didn't want to deal with pounds and kilograms, so they decided that they were going to deal with a newton. And a newton is really a kilograms times meter squared per second squared, which is really a kilogram times meter over second squared. And so we'll find out this is how we end up with a joule. But nonetheless, let me not confuse you. Just know that when you see the word, the letter N, that means a newton, and a newton is a form of weight. So then if we know that we have a height and we have a weight, we know that the carriage is sitting at the top of the hill. So the carriage has what type of energy? And we should know by now that it's potential energy because it has the potential to roll down the hill. It just hasn't yet. So if we work out number 2, like we did number 1, we start with potential energy. So I write that as PE, or you can write it as E or P, just like we did with EK. And potential energy, as we say, is mass times height, or weight times height, as your chart says. So for this one, you'll find it's very simple. Potential energy, the weight we just plug and chug in is going to be 12 newtons, right? Because that's newton is a weight. And then we have height of 21 meters. Okay, so potential energy equals 12 newtons times 21 meters. So if we take out our handy dandy calculator and do 12 times 21, yes, I am using my calculator as we speak, we will come out to 252 newtons times meter. And if you find out, this is equal to a joule. I know, I'm funny. So 252 joules. You'll find that anytime we're talking about energy, potential energy, or kinetic energy, your unit is always a joule. So the unit is always joule. All right, so this is how we calculate our potential energy. So now I've shown you an example of calculating kinetic energy and calculating potential energy. And so you should just follow these for all of them. The first thing you have to always do is make sure you know what it is. So you have to read the scenario and decide whether it's kinetic energy or potential energy. Well, Dr. Walthall, how do I know the difference? Kinetic energy will always have velocity. It'll always have a speed. It'll always have something traveling at a certain speed per seconds, per minute, per something. As for potential energy, it will only have a weight and a height, meaning meter, inches, feet, yard, whatever. And so this is how you'll be able to distinguish between the two. And once you know if it's a potential energy or kinetic energy problem, then you can go ahead and do the equation. What you have to remember always is that kinetic energy is equal to 1/2 mv squared. And whenever you do the math, you always square first. And potential energy is equal to mass times height, or weight times height. And what you, maybe I do want to hit. So weight times height. And so once you have these two and your worksheet in front of you, you work out those problems, then you should, in essence, have no problem. So this is for the kinetic energy and potential energy worksheet. And so we'll move from here to our next worksheet. All right.